Hi, welcome to the flipped instructional session for Math 08B for Unit 413, Dilations in the Coordinate Plane. Our objectives today are to determine the coordinates of an image after a dilation and to describe the dilation that occurred when given the coordinates of the pre-image and image. We do have some new vocab. A dilation is a transformation that changes the size but not the shape of a figure. So this is a non-rigid transformation. Remember, our rigid transformations were translations, reflections, and rotations. We're also going to talk about a scale factor, which is the ratio of the side length of the image to the corresponding side length of the pre-image, which will help us when we do some math on these in a little bit. So let's fill this out. Triangle ABC is transformed to result in triangle A prime, B prime, C prime. So this is the pre-image. This is the resulting image. We can see from the pre-image to the image, it has shrunk. It is smaller. So let's describe the relationship. Because in this case, this should say dilation. Is a non-rigid transformation. The image is not congruent to the pre-image. Therefore, the corresponding parts of the image and the pre-image are not congruent, meaning not the same size. Triangle ABC has vertices A, -6, 1, B, -4, 3, and C, -3, 0. Without graphing, determine the coordinates of the new image, A prime, B prime, C prime, after ABC has undergone the described transformation. It says a dilation with a scale factor of 2. So when this number is larger than 1, when the scale factor is greater than 1, the image is enlarged. When the scale factor is less than 1, it's not enlarged, but it has shrunk. So it's smaller. So this has a scale factor of 2, and we could say that means it's twice as big. So from -6, 1, if we make that twice as big, this is simply -12, 2. We just multiply by the scale factor. So this is A prime. B prime, we change from -4, 3 to -8, 6. And then finally, I'll write it up here for C prime. Multiply by 2, and that gives us -6, 0. So 0 times 2, still 0. So that's C prime. Let's take a look. Quadrilateral, DEFG has vertices D at -5, 0, E at -4, 3, F at -1, 4, and finally G at -1, 0. Without graphing, determine the coordinates of D prime, E prime, F prime, and G prime after DEFG has undergone the described transformation. A dilation with a scale factor of 0.3. So this is under the value of 1. So our image has shrunk. So if we just look at D here, this one says D stayed the same. So we know this is not correct. -5, 0, -5, 0. We see G is the same, -1, 0, -1, 0. So we know that one's not going to be right. So if you're just process of eliminating, doesn't really help us because that's C, and maybe you wouldn't see that anyway. But if we look at these, it looks like D's are the same, G's are the same. So really we want to focus right here. But what we do is we just take 0.3 and we multiply. So 0.3 times -5 is -1.5. So that's why this works. And 0.3 times -1 is -0.3, so that's why these g primes are here. And anything times 0 is 0. So that's why that's all here. So let's check here. -4 times 3 is -1.2. Check, check. 3 times 0.3. So I always tell people, you can use your calculator, it's fine. 3 times 0.3 is, or excuse me, 3 times 0.3 is 0.9. This one says 3. So we can check one more. -0.3 as compared to -1. Yep, -1 times 0.3 is -0.3. 4 times 0.3 is 1.2. So A is correct. So all we're doing is taking that scale factor and multiplying every coordinate by that scale factor. When it's less than 1, the new image is smaller. When it's greater than 1, the new image is larger. ABC has vertices A at 1, 2, B at -4, 4, and C at -6, 1. Without graphing, determine the coordinates of A prime, B prime, C prime after ABC has undergone the described transformation, a dilation with a scale factor of 0.8. So although the math is not difficult, you have to know, what is a dilation? What is a scale factor? A dilation is changing the size. The scale factor is by how much? And all we do is multiply. So we take the 0.8 and we multiply the 1 and the 2. When we do that, we get 0.8 and 1.6. So that's our A prime. We take the 0.8 and multiply through the -4, 4 and get -3.2, +3.2. So that's our B prime. And then finally for C, multiply through and we get -4.8 and -0.8. And you just can do this on your calculator. You don't need to do that. But when you write this, for example, in a part 2 version of the test, you just put this little multiply in here. So I know that's what you did. And then you write the new. So you need to show all of this work. Last one, rectangle HIJK has vertices H at -5, 2, I at -1, 2, J at -1, 4, and K at -5, 4. Without graphing, determine the coordinates after it has undergone a dilation with scale factor of 7. So to show your work, I would just do something that looks similar to this. So we'd have -35, 14 is H prime. Multiply, so -7, 14 is I prime. Oh, this is asking for LMN. Oh, this is HIJK, describe. I'm not 100% sure. I think they mix up their numbers there. So we're just going to call these prime because they didn't tell us how it was transformed. All right. So then 7 times -1, 4. -7, 28 would be J prime. And then let's do K up here. 7 times -5, 4 takes us to -35, 28, which is K prime. So you need to show this work. If you just show the end coordinates, you would not get any credit for that. You need to show your work, and this is the work, and you need to label. For more practice, join me in the Flip follow-up or help lab, and you'll find those on your Class Connect schedule. Thanks.